And this is our fourth lesson in our inequalities unit. This is quadratic inequalities in two variables. Okay, and notice, same as usual, we need to find all values of x and y. They're going to make this guy true. The hardest thing I find students have with this lesson is they get it mixed up with finding the solution to 0 is greater than or equal to x plus 1 squared minus 3. Notice this guy, we're only trying to find the values of x that make this guy true, so our solution is going to be on a number line. For this guy, we need to find values of x and y, which means our solution is going to have to be on a graph. Okay, and of course, question 2 says, plot our solution on the graph. Exactly the same as last lesson. There's going to be two possibilities. Either y is going to be greater than the thing on the right, or it's going to be equal to the thing on the right. So same as yesterday, let's look at y equals the thing on the right, and that will be part of our solution. Oops, and that's not a 1, that's a 3. Okay, you should remember from chapter 4 that we're going to have a vertex of -1, -3, because when x equals -1, that gives us 0 squared. And fill in the rest of this table of values. So we got -1, -3. And we go over 3 up 9. So what's that going to be at 6? There we go. So there's all the values of x and y that make y equals x plus 1 squared minus 3 true. And now we need to find out where the greater part is. So we just need to test a couple points. Let's test 0, 5. So that gives me 5 is greater than or equal to -2, and that is true. Okay, and now let's check a point on the other side of the parabola. So let's check down here at 0, -10. So we get -10 is greater than or equal to -2, and that, of course, is false. So my solution is going to be on this parabola or anything on the inside of it. There we go. So that's all the values of x and y that are going to make that inequality true. Okay, and same as question 3 yesterday. That doesn't equal to, so our parabola is just going to be the boundary between the true part and the false part, between our solution and not solution. And that boundary is going to be at -y minus 2 equals x plus 3 squared. And now let's just rearrange, let's just rearrange this a bit so it looks a little more familiar. Multiply both sides by -1. Okay, so that's where our boundary line is going to be. And the vertex on that is going to be at -3, -2, and then we've got a normal shape opening down. So over 1, down 1, over 2, down 4, over 3, down 9. So that's going to get us down to -11. There we go. So there's my boundary between the true part and the false part. And now I just need to do 2 test points. So let's grab one inside here. That's -3, -10. that's 8 is less than 0, which is false. And let's try this point up here. So negative 3, 5. That's going to give me negative 7 is less than 0, which is true. So not including the parabola, but everything outside of it is going to make that inequality true. So everything not inside that parabola, not including the parabola, will make this inequality true. Okay, question 4 is exactly the same as question 4 yesterday. So we need to get the equation of the parabola first. And we've got the vertex, so we know that that's going to be y equals, we don't know a, but we do know that's going to be x minus 0.5 squared minus 12.25. And now let's choose a point. We'll throw that in. So we end up with 0 equals a negative 3 minus 0.5 squared minus 12.25. That doesn't look like a 2. So let's add 12.25 to both sides. So I get 12.25 equals negative 3.5 squared, which is not surprisingly 12.25. A, divide both sides by 12.25. We get a equals 1. So we know our equation is going to be y equals x minus 0.5 squared minus 12.25. Okay, and now we need to figure out which way our Pac-Man is going to be facing. So we get y something, actually. Yeah, it's going to be y something x minus 0.5 squared minus 12.25. If I plug in any point from the true area, so let's try this guy here. What's that, 10, 0? That gives me 0 on the left and 78 on the right, which means that our Pac-Man must be facing that way. So the graph on the right represents the solution to this inequality here. It's all of the points, or it's all the values of x and y that make this inequality true. It is right there.